In this section, we want to explore some ideas about complex numbers. And just to kind of give you a little bit of review on what a complex number is, I got some stuff on the board I want to share with you. First of all, if you remember, a complex number had both a real component and an imaginary component. And a lot of times we wrote that in the form of a plus bi, where a represented the real number and this I represented the imaginary number. And this I, if we remember, I was what we used when we got to the point or discovered a square root of a negative number. Specifically, we identified I as a square root of -1. And then if we squared both sides, I squared would equal -1. So complex numbers, and specifically imaginary numbers, we discovered, we didn't invent them, we actually discovered them. They help us to understand what to do when we want to take the square root of a negative number. And we have found many times that that is, even though we call it imaginary number, probably not the best term, but that's the term that's stuck. And with all complex numbers, we can do all the operations. We could add, we could subtract, we can multiply, we can divide. And so over here I have a multiplication that I want to just kind of help remind us of how we can multiply these two ideas. So I have basically two polynomials or two binomials, which means that I can go ahead and use FOIL. So I can go first times first. Outers, that's a plus of 10i. Inners, -12i. Outers is a -15i squared. And then from there I can clean it up a little bit. I have 8 plus 10i minus 12i gives me a minus a 2i, minus 15, and if we remember, I squared equal to -1. 8 minus 2i plus a 15, and then I can add the 8 and 15 to give me 23. So 23 minus 2i is the product of those two terms. And so I hope that reminds us a little bit that we have seen these before and we can deal with them and we can work with them. Well, we also want to introduce to you a way that we can graph those. Before, if we were able to graph a real number, the a in that particular form, we would graph it on a number line, where we might have some 0 and positive numbers out to the right, negative numbers out to the left. Well, to graph a complex number, we introduce to you a complex plane, which means that we're going to add another axis onto it. It looks just like the XY axis, but in this case, it has the x-axis represents the real numbers, and the y-axis represents the imaginary part of that complex number. So over here, I have 4 examples of values or points that we want to go ahead and identify. And we're going to call this point Z to represent the point on the complex plane. So where's the point Z that matches up with the complex number 3 plus 4i? So how I would do that is I would go over the real number on the x-axis 3, and the I represents my vertical distance, up or lower, up or down on the complex plane. On that case, I'm going to go up 4 units. 1, 2, 3, 4. And right there, I have the point 3 plus 4i. The next one, the point Z, -1 and -2i. What do you think we're going to do? Well, -1, we go backwards on the x-axis, and we're going to go down on the on the imaginary axis. And I have a point there. That's the point -1. Whoops, sorry, the point -1 minus 2i. Z equals -3. It is still a complex number, even though in this particular case the imaginary number is omitted or it's missing. Basically, it's 0i. We can still graph this point Z on the complex plane, and that's on the point we go backwards 3. And that point actually just stays on the x-axis, but we still put it in the complex plane. And then likewise, this last one, the real part of the number is absent. We just are left with the imaginary part. And so we probably get a sense that that's going to be on the y-axis, or in this case, the imaginary axis, down 4 units. 1, 2, 3, 4. And there I would put the point -4i. So I hope that's a little bit of a review for us as we move forward in this section, as we start to explore complex numbers, and we're going to explore them in polar form.